Very good morning to all. We'll start the EP session with a basic talk, that is EP lab setup. So the rationale will be to get a EP lab which will give us a crisp signals without noise. So that will be the biggest challenge in setting up an EP lab. So we'll be covering some of the aspects of it, and recording signals and things will be taken care by the next speakers. So what is the issue with EP lab? So as such, you know that there are multiple electromagnetic radiation which can impact. It's not changing. Okay, it can impact the EP lab proceedings. Okay, as such, if you see, when the fluoro machine is not on, okay, there is a minimal background radiation which can impact the millivolt signals which you get from the electrical signals. So when you switch on the fluoro machine, you'll get more and more of radiation which can impact your electrical signals. So these should be negated, and most important for this negation would be to change the to get a good grounding. So that is the reason why grounding is so important. So in most of the labs we have at least 3 or 4 grounding works which will be done. So in our lab we have almost 6 things, 2 for 2D systems and 2 for 3D systems. So this is so important. Even when you go and set up a lab, you need to look at which are the electrical appliances which are being used in the lab, and which are the machines which can give you a trouble in getting the signals. So then getting back to the equipment component as such, okay, there are multiple vendors for different equipments. It depends on how common you use it, how well versed with your system. Okay, you can take up any of the equipment and set up the lab according to it. So the overview of it would be something like from the patient, different electrical signals either from the surface ECG or the diagnostic catheters or the ablation catheters are routed into the junction box. From there, it is rerouted into the stimulator and to the ablation system. From the junction box, the signals are amplified and filtered and sent to the computers for display and also for storage. So this is the overview. So here, what you see here, when we zoom into the patient alone, okay, when you zoom into the patient alone, there are multiple connections over him. One is the 12 lead ECG and the defib patches in some cases, and the indifferent patch for ablation. So these are the connections to him where the contact should be good enough so that he will the impedance and everything should be managed. And when you use a 12 lead ECG, try to use a 1 millimeter patch electrode so that you get a crisp signals. So it starts from the patient. When you start from the patient, okay, prepare the skin for the surface lead connection. Do not use excessive alcohol because it might lead to sometimes increased skin impedance. After connections to the patients are established, the excess cable should be rolled up and put on a tabletop. It should never be lying over the floor or going across, touching the floor. And check surface ECG with the notch filter off, because notch filter is mainly for the AC current noise which would come into play. Many times you switch off the notch filter and then check if there is a notch, if there is a broad noise which is present, or sometimes you need to switch on the notch filter. This is not all the time mandatory in many of the labs. So going back to the connectors, you could see from the catheters, you get the connectors which will have pins which will get inserted into the junction boxes. So usually the distal pin is coded red. Okay, so the distal pin will also carry the smaller number. That is, if a catheter quad is used, it is 1, 2, 3, 4. The distal pin will stand for the 1. So from there, connect to the junction boxes. So junction boxes will send the signals to the amplifier, which will filter out and then relay it to the computers, which can be used for displays. So the most important when you connect the pin would be, as I said earlier, is about the distal pin, which should be assigned the smaller number, and the proximal pin should be assigned the larger number. And the positive electrode in a unipolar signal when you are recording, it should be used as a distal pin, and the negative as a reference. The negative can be either your Wilson central terminal, or you can sometimes use an IVC electrode for using that as a reference. So, and then go to the setup page. When you go to the setup page, use your bandwidth filter. Okay, try to look at the gain, the gain should be just above the noise level. Okay, sometimes when you're mapping in a SCAR VT or something like that, the SCAR would be of very micro signals. Sometimes you need to increase the gain up. But sometimes in cases where you want to, there are increased electrical signals, you need to decrease the gain up so that you don't overlap a signal in your system. So gain up, clipping also should be done accordingly. Okay, don't clip the ablation catheters because you need to see the signals of interest for ablation. And always use your bandwidth filter. One for the surface ECG, it should be from 0.05 to 130 or 100. On bipolar, it should be from 30 to 300, and for unipolar, it can be opened up from 0.05 to 1000. So these things can be used. And amplifier, it usually amplifies the signals to a visible level and filters out any unwanted noises. This amplifier filters will send them to the monitor for observation, which will be then used for us for interpretation. So, so when you look at these things, so what is the most important would be getting these signals from the patient to the amplifiers without any noise. So that becomes the first important step. So then we have multiple ablators from where the RF catheters will be connected to, in will be going to one of the ablators and the out will be coming to the junction box. There are multiple ablators. These are the old types where now ampere is the commonly used in our lab, which will again be used. So from here, cardiac signal will be processed. It will be digitalized and then be displayed into your monitor. So when you display the signals, what we want to see is first set up a page for ECG, okay, which will have a clear cut without any notch, without any noise which will be found in the ECG. Next, set up a intracardiac page and then set up a ablation page. So these things should be properly set up in your AP system. And for every module, something like an SVT module or a VT module, you keep up your connections and make that you use the connections all the time. So do not jumble up or try to change your connections all the time. Next slide. So all the time to get a good signal, okay, it means that you need to be really meticulous here. You need to keep your EP systems connected promptly, and also after finishing the case, you need to preserve them properly. So what you sow, so shall you reap. This is good for even signals also. So there should not be jumbled wires. Power cables with electrode cables should not be mixed up. If you're using a same extension box for connecting a power cable with your electrode cable, try to use a wooden box and try to keep it little away from each other. And touching of cables to the ground should also be avoided. Next slide. So this is most important, which will cause much of a noise in this. And one more important thing is when you're using a 3D system, your optical fiber cable should be insulated and should be going across to the 3D machine. Next slide. So rule number 2, again, power cable and warmer cables should be separate from the EP cables, because whatever signals you get from the EP system would be a microvolt or a millivolt. But whatever you use from an high volt, either your warmers or even your power cable, will be at high voltage, which can have an interference with this in signal interpretation. Next slide. So when you use a junction box, when you use a jumper cable for using unipolar signals and all those things, when you remove any of the jumper cables which are not being used, and never leave one end of the jumper cable connected to and left hanging in your junction box. And even in for electrical appliances, if you're not using an infusion pump in your EP lab, try to switch off the infusion pump so that you reduce the noise there. Next slide. So irrigating catheter and tubing, okay, this is one of the things which you can always use to reduce the noise, where you can use a anger from which an irrigation can be used. But we don't use it much in our lab, but this is a system which is all the time used in many of the Western labs. Next. So ideal setup in an EP lab should be, okay, there should be a short distance between your junction box to the amplifier, so that your amplifier or even your patient interface unit should be as close as possible, and try to use as much as insulation for your optical fiber. And when you are using your ablators or stimulators, use a boom from which you can hang so that it doesn't lie on the ground and none of the cables go touching the ground. That is most important to get an ideal setup to give a crisp signals without any noise. Next. So even after doing this, you might get a lot of noise in your EP lab. Okay, so many of the times our EP tech would keep on plugging it, okay, plugging off and plugging it to see if the signal improves. But most important is follow a usual algorithm whenever you find a noise, right? So you start with whenever you find a noise, you start either recheck your surface electrodes. That will be the most important issue in many of the things, many of the noise, and check interface cables. Your re-sterilized cables can also become stressed many a times. So that can lead to these kind of things. And if that are normal, check your peripheral unit, your amplifier and all those things. If other problems are not found, then there is a good chance that the catheter is problem. Okay, if there is a problem with all of the catheters, either your junction box is wrong or with the amplifier is wrong. And if this is a problem with one of the catheters alone, your catheter electrodes may be wrong. So try to change that. And even if that is not improving, then go try to look at switch off and switch on the machines and see whether the noise improves. And apart from that, if you get a noise, there can be muscle twitch or physiological things which can happen in the patient which can cause the noise. So if I had to conclude, next slide. Okay, so whenever you set up an EP lab, start from the scratch, inspect the space in which you are going to set up an EP lab. The simple steps ensure good contact. Signal cables should be separate from the power cables. There should be no loose or coiled up wires. And just like tender loving care of the patient, there should be tender loving care of the catheters and the connectors. And signal processing should be used using appropriate filters, and set up a page for each and every module which you use. Thank you. Happy EP.